Hello, Ken Leong. Do you
Yeah,
know when was the last economy take off by Malaysia, our country?
think it's around 1988 until 1997.
Wow. So the whole country is expecting the second economic take off. Do you know when it's going to happen?
For this, I don't know.
You want to know more? Let's
That's
Sembang
the
here.
LT.
Hello. Very good afternoon to all of you. Yeah,
Yeah,
nice. Wish you a nice weekend later on ahead. So I'm at the north here. Yeah, today. I think I haven't. We haven't done anything like that remotely.
yeah. This one is first time.
This is the first time. I'm at the north at our Penang office. How are you, everyone? So welcome to our this Let's Sembang AIoT channel. I'm Cecily.
I'm Ken Leong.
So after doing how many rounds already? This is our 63 episode, right?
Yes, this one 63.
63, yeah. So after doing the 63 episode of this Sembang IoT, I would like to thank you for all the support and all the viewer, follower who has been following us for till this point of time. I think from the beginning until now, we were talking about very technical subject lah, yeah, very technical subject and some application, especially related to by the name AIoT. Recently I think I've gone through several rounds of AIoT explanation. What is this AIoT? What is this AIoT?
IoT is the AI plus IoT.
Okay, but to us, you didn't get that part. Okay, the AIoT for Axiomtek Malaysia, especially, or AIoT mission, meaning AI and a fusion of AI and IoT plus the automation. Yeah. So the A in front actually stands for automation. And automation start first, then AI and IoT. That is our definition. Okay, thank you for watching. For all of you who have just joined us, I think if you have any question or any idea or any comment, please do give us some comment. We appreciate your time for watching and also suggestion. So to start off this today's Sembang AIoT, I would like to just touch a little bit more because I think up to the episode number 63, all this while we were talking about mostly technical, but to Malaysia, to Malaysian economy especially. Recently, I just came across a book by our Deputy Minister, YB Liu Jintong, Mr. Liu Jintong. So I'm quite impressed by the some of the so-called announcement and also the books that he actually wanted to publish. Yeah, I think it's not officially published yet, according to the news that I watched. But I'm very impressed in that kind of what they call the hopes, especially for the old Malaysian, especially those who are in the industry area. Yeah. So especially we are talking about technology, we are talking about adoption of technology for IR4 and so on. These are all related. That's why today's I would like to just kickstart with this second economy takeoff. Yeah, second takeoff. When is it going to happen? So so of course, I think just now Kenon mentioned about 1988.
Yeah,
1988. That time you were not born yet. Yeah?
yeah. I'm not born yet.
That was my first college time. When I enter college during the 1988, I'm a first year microelectronics. Doing the microelectronics physics during that time. So 1988, and then the period is from 1988 to 1997. That was the time where the economic crisis for the whole Malaysia, especially the whole Southeast Asia, basically Malaysia also badly affected, 1997. Yeah. So over the period of 88 to 97, actually, we didn't feel anything, but then we also don't know whether this is considered a first takeoff or second, whatever takeoff, we actually don't know. But during the time, I was also engaged in my starting of my career, and also building up a business, venture into a business until now. So that's why that thing actually attract me. It's attracted me. When I saw the news. So when is this second economic takeoff? Because the first takeoff actually we didn't actually go and feel, and then we also don't know what are the contribution that we have done. What are the things that we help the country to do this part. Actually, we don't know. Yeah, but then along the road, actually, after I recall that, you can, I actually admitted, I acknowledge that there is a economy, the booming time, take off time, especially in the semiconductor sector. Yeah, in the 1980 overs, like for example Motorola, Western Digital, National Semiconductor. Last time, it's called National Semiconductor. Now I think it's called, what is that name already? Bought over by someone. Yeah. So Harris, and there are many, and then Japanese manufacturing also, like Sony, JVC, Panasonic, Matsushita, last time called Matsushita, and there are many more, from Japanese. So that was the time of the economy is so well, so good, so everybody is enjoying. But then after that, 1997 up to now, we actually, whether know or unknown, so you are going through this part. Actually, you don't see, it's a kind of declining. It's kind of declining because more and more FDI, the foreign investment, for foreign direct investment, has gone down. People moving out, moving out. So moving to where? Moving to Vietnam lah, moving to China, moving to, there are many these FDR actually move out. So that actually is a kind of declining. But after looking at the some of the content that this author, Mr. Liu, this YB Liu, talking about, this second takeoff, I'm quite attracted to get to know what is actually going on. So maybe this is one part that we want to kickstart this part, so that after going through the books and some of the content that he has created, we want to make that part as one of the discussion point where we can discuss more. How can this happen? Or do you believe that it's going to happen? Or what if, let's say it's happened, what do you want to see as a normal citizen? What do you want to see? As an industrial player, what do you want to see, or what do you want to benefit, or what do you want to contribute? These are the things that I think will be more relevant to some of the industrial player. So Kenyam, let me ask you, do you have any idea, let's say the second economic take off for Malaysia? What do you actually wanted to see?
More job opportunity.
More job opportunity, okay.
Yeah, and then
Of course, more job economy, meaning the economy is moving better lah. So I just want to share this part first before we move on to our topic today. Today we are going to talk about what?
Today we are going to talk about energy monitoring with the IoT and AI.
Yeah. So before we go into my sharing here a little bit more, but I just want to highlight energy monitoring, or this power, especially power monitoring, is so important, especially in the what you call the carbon emission. Carbon emission is all related to green energy or carbon emission, plus optimization. What kind of forecasting things like that AI or IoT can help. Before that, I will just share myself. I don't know whether I can share this part. Let me try. So this is a book. Can you see? Can you
Yes,
see my
can.
slide? This is a book that I'm talking about. The second take-off strategies for Malaysia's economy resurgence by this YB Liu Jintong, and then he is right now our Deputy Minister of MITI. Is it MITI? Ministry of Trade, yeah, it's MITI. Okay, this is a part, and then let me see whether I can show something. Oh, okay. So maybe I just want to share this part. This is related to what? Let me see. 1 second. Okay, let me share again. I'm still showing this. Actually, I don't have a chance to just show like that, because I'm on my laptop. Then only I can see. Usually, we stand there, we cannot we cannot share like that. Okay, hold on. Okay, can you see this slide? Can you see this slide?
We can see.
Okay, this is one of the report, and also one of these NIMP 2030. I think we mentioned in our this Sembang AIoT channel this live before. This a new industrial master plan. Okay, I think the second takeoff is going to be very related. It's related to this NIMP 2030. So let's see, if let's say I read out to you, the new industrial master plan NIMP 2030 aims to improve the manufacturing sector. That is a point, why we want to talk about that, because all this while we want to connect, we want to connect how technology adoption in the manufacturing, that is also why I want to make this one as a part of our sharing. The manufacturing sector in Malaysia is also a key component of this Madani. Madani is our new government economic framework. Okay, that is one part. The second part I want to highlight is this, what are the key goals? Can you see this part? What are the key goals? Are you able to read the first?
So the first one is increase the manufacturing sector value added by 61% to 587.5 million by 2030.
Yeah, billion by 2030. So as recorded, 2022 is 364.1 billion. So there will be a compound this CAGR of plus 6.5%, by 2030. So if this happen, I think that is definitely a takeoff basically a takeoff. The second one will be the increased employment. You want to see an increased employment by 20% to 3.3 million by 2030, and then the CAGR of plus 2.3%. Okay, We are not good in economics, but then from our figures, at least we can connect lah. We can connect. I hope, I hope we can connect lah. Connect to the this I mean the activities, especially in terms of innovation, technology, and so on. So the last one will be the increase the median pay by 128% to 4510 in 2030. Okay, it's an increase of 9.6%. This is definitely a kind of boost in our economy. So that is the thing. But then, what are the effort that the government is able to do, or what are the things that as Malaysian, what are the things that you can do, or what are the things that you can contribute? So that is another thing. So I think I'll just share my slide. Okay. So my slide is off. My screen is off there. Okay. So that is the key thing about this second take off. And then, according to the minister, the other day I was following, we were following that. I'm actually following quite closely, what it has seen, what has this this government, or what has this minister have in mind, how to make a second take off. So one of the subject that he mentioned about, the Malaysia shouldn't be only relying on the FDDI, but of course have to encourage more domestic direct investment. That is also very important. But the most important is to create, or to energize more innovation, because by doing the innovation, of course, innovation has to come from the technology, for what we are doing. Okay. So innovation usually will tie together with this technology. So by increasing the innovation, then only you will be forced to don't it's a kind of a trade-off because you do a very manual thing. You hire more foreign worker, low pay foreign worker. The innovation, actually you don't need innovation. It will pull you down. So that is the whole thing about why innovation is very important, so that you do not need to rely on those low cost labor, in the sense that when we're running, or most of the process, or even in the daily life. So which I think is key important. Let's talk about that in our coming session later on, and we will share more, and then we will discuss. If you have any comment or any, we welcome all those the economics expert. Maybe you can share more with us about this part. So let's come back to our this main subject on the technology part. Maybe Ken Leong, you would like to talk about. I'll leave this part for you to talk about how the previous way of power monitoring, and how this IoT or AI will be able to help in this kind of industrial transformation, or this kind of how you can benefit from this area, especially on the power and energy monitoring. Maybe Kenong, you can take on from here. You want to share some slides, or how?
So previously, so before the IoT and the AI, so how we do the power monitoring or the energy monitoring is usually we still need some sensor to get the reading out. But at that time, after you get the reading out, because you don't have the IoT technology to share the data to other place or to other software, so usually people will write it down at somewhere and then manually key into the computer. But with the IoT technology, now we can directly get the data out from the power meter or the energy meter, and then the data can straight away transfer to cloud or to other database to keep it somewhere. And then for the data analytic part, and then previously before the AI, then the engineer in the factory, they need to manually study the data, plot the graph, find the pattern inside the data, and then try to do some forecasting, based on the data, they do the predictive maintenance. But that one is all based on their experience and based on their knowledge. So it's need a lot of human power to do this. So, but now by using the AI, we can automate this process, and then we will less rely on the human to do this part. So, and then for today's topic, so we have a case study here. So it's the energy monitoring in manufacturing. So this one, let's say today this factory is to produce the valve and the actuator. So in the process of producing this kind of product, so it involves some welding, painting, and some machining job. So, and besides all this, in a factory, of course, you also have the administration part, the office, and then even in some large factory, you also have the canteen inside, or some other facility inside. So all these things, it will require energy to operate. So in order to find out how to do the energy monitoring, usually we need to look into the entire picture. So if, let's say, if we want to monitor for the entire factory, then you need to look into all the departments. So in this case, we have few departments over here. So for example, the machining department, the office, the welding department, and then the testing department also inside. So every department, they have their own energy consumption. So some department got a lot of machines, some department don't have so much, and then some department, they operate for 24 hours, and some department only operate when there's a demand. So all these things will lead to different kind of the energy usage pattern. And if, let's say, this kind of thing is done by the human to analyze the pattern, to do the forecasting, so there's a lot of job need to do. Maybe you require a team of people to do this thing. It's not, I think it's very hard to done by an individual person. Okay, so let's move to the next slide. So usually how they do the monitoring. So one of the way is they install the power meter at the electric cabin of each department. So this is one of the way if we want to get the overall energy usage or power usage of that department. So this is one of the way we install the power meter over there. And if, let's say, if you don't want to do it at a large scale, you just want to monitor the energy usage or the power usage of that floor. For example, that floor only contains the machine, then you can and then you want to study the energy usage of individual machine, then you just install the power meter for individual machine. So there are many ways to do this thing. Okay, so now we move to the next one. So what are the objectives of doing this? So the first one is we want to monitor the plant energy consumption. And then the second is we want to map the efficiency of department. So for example, the welding department, so they consume this amount of energy. Is this equivalent to how much of the work they produce? And then at the same time, we can do some comparison. Why this production line, they utilize this amount of energy to produce this amount of good, but another production line, it requires more energy to produce the same amount of goods. So this one, by study this one, we can know the efficiency of each department or the production line. And then the third one is to exploit the potentiality of energy efficient strategy. So after you discover there's such a problem, different production line, the energy required to produce the same amount of goods are different. So you need to find a way to coming out a plan on how to do this, to solve this problem. And then lastly, to promptly react at the production planning and control level. So by doing the energy monitoring, it actually relates to your production planning. So how you're going to carry out your production plan, and how you're going to control all the raw material, actually it affects the entire production process. Yeah, okay. So we move to the next one.
Okay, before we move into the next one, the next slide, just want to ask. From my experience, most of the power monitoring, most of the factory they don't care. Also, they didn't monitor. But if let's say those people who have done that, they usually will use some SCADA system. Usually SCADA system is being used quite what they call frequently in this manufacturing site. So, for example, their machines, their what utility, and some of the spatial process, they do actually track those things. Yeah. So that is still a very conventional way of SCADA monitoring, where you actually capture the data and then you put into the database. And most of the time, this data has been kept there for many years. But they didn't do anything about that. Yeah, they didn't do anything about that. So with the current AI, this advancement of AI, do you think this part will be needs, or also is wise to use AI to do some analytic to do some optimization?
Yes, of course. So if they already have a lot of this kind of data and didn't use it, for me, it's kind of a waste. So usually the AI can help them by feeding this kind of data into the AI model. The AI can help them to do some forecasting, the prediction, even if they want to do the predictive maintenance. This is also possible. I study the power usage of every single machine. So if let's say some of the machine, the power consumption suddenly become much more higher, but their productivity still the same or become lower. So these are some of the symptoms that the machine requires some maintenance soon.
Okay. You may move on from here, Avilam.
Okay, so to achieve the objective here, what we need to do. So the first one, we need to collect the data, record and visualize the energy consumption data. So usually we need to have a power meter, a sensor to collect all this information and then send to a IoT gateway or even to your current existing SCADA system. That one also can. And then usually we need to visualize the energy consumption data. So we will plot it into a graph, a chart, and then we do the comparison by day, by week, by month, by years. Then we do the comparison across different machines. And then we need to have an overall idea on this department consume how many percent of the overall energy, and then another department consume how many percent of the energy. So all this information will give you some insight on what you should do next. So next, we can compute the energy-related KPI to measure the plant energy behavior. So usually, every factory, they have their own way to do this one. So for example, maybe they compare the energy usage between the shift 1 and the shift 2 and the shift 3. So because every shift they might doing the same thing, but why certain shift then require more energy to complete the job. So even though their products are the same. So usually for this kind of comparison, they have their own formula to calculate, to do the comparison. So the next one is to integrate the energy and production data for performance evaluation of the plant energy efficiency. So now is the time, since you already collect the energy data and you have the production data, so you can relate them together and then to find out. So when your energy consumption increase, does your production increase also? So if not, then what is the reason in behind? Okay. And then lastly is to identify the critical situation for the performance enhancement. So you need to identify, based on this kind of data, identify what is the root cause, so and where we can do the improvement. So these are the 4 steps, the general step, what we can do after you gather all this energy data. Next one. Okay, so the previous step, there are general steps. So it seems like maybe it's too difficult for some person to implement it because it requires some technical knowledge to do it. So one of the way to help you is actually you can use the AI to do this thing for you. So what the AI can do is, the first one, the very basic one, the abnormality detection. So instead of you ask someone to monitor the graph all the time to find out is there any abnormal energy usage pattern. So actually you can use the AI to do this part. It can help you to identify the unusual pattern in the energy consumption for the entire department or for every individual machine. So this one is possible, provided you have enough number of data to train the AI. And then, yeah, after the anomaly detection, you can able to achieve, then the next one is the predictive maintenance. So you can prevent the equipment failure by monitoring the power usage pattern. And then the last one is the optimization. So now with the generative AI, with the technology of the LLM, so we can use the AI-driven insight for enhancing the energy efficiency. So for example, if you have 1 year of data, so you put into the LLM, so then you can ask the LLM how to improve the energy consumption for certain department. So if you have enough number of data, I believe the LLM able to give you some suggestion on how to improve the process and how to reduce the energy consumption or use the energy in a more efficient way.
So when you speak about this LLM, basically a Gen AI lah, okay, Gen AI. So we do require some existing historian data to get the model trained first, right?
Yes, usually we need at least 1 year of data.
1 year.
Few days is not enough.
Okay. Okay. Okay, you may continue. But then before that, when we talk about energy and power usage, there is one category under the utility billing, especially for the electricity. There is a part called maximum demand. Maximum demand. So let's say the utility company give you the kind of a quota for you, but that is based on the rate. Let's say you are overused, so over the so-called maximum demand, so you'll be billed in a different rate, higher rate or something like that. So that's why I think instead of having human being keep on looking at this part, that's why AI, this kind of innovation, AI will be able to play the part where after teaching them, so they will know roughly when was the season, when was the right time for you to make use of your energy more, or you have to do it more moderately so that you won't eat up the kind of maximum demand thing, for being overcharged for that purpose. So I think that will be a more values that can be brought to the owners, where this part actually is taking out money. At the same time, also it also help the carbon emission, in running or use the energy wisely. Yeah. So that part is very important. So do you have any more thing to share? Kenneth?
Yeah, I think the last slide is to share the architecture of the system.
Yeah. So for this part, actually, we have a demonstration way back in about last year. Last year we demonstrated this part. I think we have a panel showing. We got two ways lah. One of them is using a 4G gateway routers, IoT gateway routers, and also one of the Axiomtek IoT Edge gateway. You are able to use that also to publish data to the cloud. So of course, publishing data to the cloud is one thing. You can visualize the data, but then the second part is most important thing is, let's say we can have this AI engine running to watch, to help to regulate or watch, to create kind of action-based workflow let's say to reduce, how to reduce the energy consumption, or give you alert, or early warning what to do or what not to do. That is another part. So basically, if let's say I want to track this set of data, what are the equipment that we need to use for in this architecture?
Yeah, so the first one, you need an energy meter or power meter. So as shown in the slide on the left-hand side, that one is a power meter. So usually depends on the type of the power meter. So if let's say the power meter don't have the ability to connect to the internet, then you usually need a IoT gateway. So for example, in this slide, we are using the 4G router, so that can do the MUBUS pooling from the power meter, and then it can publish the data to the cloud through the MQTT or through the RESTful API.
So that thing without we actually this set actually we do not need any programming at all, right?
Yeah,
just by
no programming at all.
By configuration, and then your data is up. So it's good that this data is able to be collected as early as possible. So for that part, I will just we want to make a reserve that we are not going to show this part demo. I think we have a demo later on. Maybe we can show it in your next coming session. We have this connection to some of the air condition system that you can see what kind of energy is consuming. That one is actually going to do in our office. But then most important thing is what we want to do is we want to track how does this energy consumption, how does it relate to the efficiency of the compressor in what they call in the air condition system. That is the thing that we want to track, and especially if let's say the energy. We are expecting hypothetical as expecting that the energy consumption will go high when the efficiency of the compressor is not good. First thing, or the some wear and tear thing is not doing well, especially the fan or this kind of rotating fan to cool down the thing is not good, or it can also relate to this. The environment, or the usage, and plus some of the weather thing. Yeah. So that part, I think, if we will do a demo to you. Yeah, demo to you live. That is the thing that we want to do, especially if we can see all those things in the cloud. So so this part actually, energy. Actually, when we come to this energy, like. The diesel recently, in our country, diesel price has gone up. Industrial usage of the energy the cost will increase. Yeah, the cost of it thing will increase. But the cost of the energy increase, meaning our what they call the inflation, inflation will start to be more obvious. And then how can you do that? Let's say, so more and more, especially manufacturing or the owner of the factory or something like that to produce those things. So they have to control the thing, the energy usage, and then they have to be more cautious in terms of running the energy, because some of these thing is run by generator also. Some power is really generated from the diesel, all those things. So by switching to this energy, last time they rely on diesel, or they right now move to the normal utility company, the consumption will be higher, but they should be more cautious in terms of using that part. So that part of innovation, I hope, especially when you use AI or IoT or AIoT, to make sure this part is properly managed. That I think will be the aim, especially for this innovation part. Of course, this will impact more manufacturing company. That's also why we want to bring this thing up. If let's say any of you or friends that having this manufacturing plant, we would like to hear more from you. How can we use the technology to help you in this area? Yeah. So by the way, for those of you who is watching us here, we are on this Let's Sembang AIoT, and then we have come to the end. We have come to the end. So this little sharing today. We hope you a good weekend, and then we will see you in the next coming session. Okay, see you again. Bye bye.
Bye bye.